Dear students, today we see about the boron trifluoride structures, bonding, reactions, synthesis, and the applications according to the valence bond theory or the VBT. Boron trifluoride is the inorganic compound with the formula. It has a formula BF3. This pungent, it has properties that is pungent, it is colorless and toxic gas. Forms the white fumes in the most of the air. It is a useful Lewis acids and versatile building block for the other boron compounds. And the inner structures and the bonding. The geometry of the BF3 is the trigonal planar. Its D3H symmetry conforms with the predictions of the whisper theory, that is valence shell electron pair repulsion theory. The molecule has no dipole moment by the virtue of its high symmetry. The molecule is isoelectronic with the carbonate anion, that is CO3 2-. The BF3 is commonly referred to as electron deficient. Descriptions that is influenced by its exothermic reactivity towards Lewis bases. In the boron trihalides, BF3 length of BF boron and the halide bond, that is 1.30 angstroms, is shorter than would be the expected for the single bonds, and the shortness may indicate stronger BX pi bonding in the fluoride. The facile explanations invokes the symmetry allowed overlap of the p orbitals on the boron atom with the in-phase combinations of the three similarly oriented p orbitals on the fluorine atoms. Other points of the ionic natures of the bonds in the BF3. In the synthesis, BF3 is manufactured by the reactions of the boron oxides with the hydrogen fluorides. Typically, the HF is produced in situations from the sulfuric acids and the fluoride. Approximately 2,300 to the 4,500 tons of the boron trifluorides are produced every year. Or in a laboratory scale, BF3 is usually produced in a situation using the boron trifluoride etherate, and which is a commercially available liquid. Laboratory routes to the solvent-free materials are numerous. A well-documented route involves thermal decompositions of the diazonium salts of the BF4-. It forms by the treatment of the mixture of the boron trioxides and the sodium tetrafluoroborate with the sulfuric acids. So it has a properties that is it is anhydrous. Boron trifluoride has a boiling point minus 100.3 degrees centigrade and the critical temperature of the minus 12.3 degrees centigrade, so that it can be stored as a refrigerated liquid only between those temperatures. Storage or the transport vessels should be designed to withstand internal pressures. Since refrigeration system's failure could cause pressures to rise, the critical pressures of the 49.85 bar. Boron trifluoride is corrosive. Suitable metal for equipment handling the boron trifluoride includes stainless steel, monols, acer alloy. In presence of moisture, it corrodes steel, including the stainless steel. Its reaction with polyamides, polytetrafluoroethylene, polychloroethylene, polyvinylidene chlorides, and the polypropylene show the satisfactory resistance. The grades used in the equipment should be the fluorocarbon based, as boron trifluoride reacts with the hydrocarbon based ones.